In section 6, and this is an extra section, we're going to deal with quadratic functions and their graphs. And we're going to look at three basic functions. F of x equals ax squared. And then there's our a, and then we are adding something inside here which is going to shift the graph either right or left depending on the value of h, which is sort of your x value, as you'll see here shortly. And then we're also going to add to this where we have added k, and k is going to move the graph up or down. And all of this will be illustrated by the slides. They do a nice job. So the graph of f of x, again function notation, is equal to ax squared. Now remember, we had said in the past that f of x can be replaced with a y, as they're showing you over here. So we have y equals x squared. Now this basic shape of a graph where you have x squared is a curve that is called a parabola. They're usually U-shaped, and they are symmetric with respect to a vertical line that's going up and down, known as the parabola's axis of symmetry. Symmetry means that things are sort of the same on one side or the other. If you had a piece of paper and you fold it along the lines of symmetry, then the sides that you fold would match. And when the equation is in this form, the axis of symmetry is the origin. And the origin is also what we call the vertex of this parabola. That is where the base of it, if it's opening upward, or the top of it if it's opening downward. And we'll illustrate this as we go on. So the first thing they want us to do is to actually graph one of these. Now I would have started with f of x equals x squared without the 2 there. Remember, 2 is sort of our a term, and we get values. Let's look at this little t-chart here. As we set up a little t-chart, if x is 0, then y is going to be 0. If x is 1, we're going to square 1, and that gives us 1, and then 2 times 1 is 2, so that's 2. And notice if x is negative, it comes out the same as if it were positive because we're squaring it. And then if it's 2, 2 squared is 4, 4 times 2 is 8, and there we get a series of ordered pairs. Now when we plot this, notice there's our vertex at 0, 0, and then these are our points, and our axis of symmetry is actually the y-axis with the point of vertex, as we said, the origin. And again, you're going to have to build on this little by little. Now here we're dealing with the function of a negative 3x squared. And what this does is it always makes our y value negative. So again, putting points in there, and since it's just this ax squared, so to speak, our origin is the vertex. And depending if we have positive or negative, remember as we square x, this will always become positive, but then we multiply it by a negative 3. So our y value will always end up negative. So when you plot these points, as you see, it's a parabola, but the parabola now is opening downward. But our vertex, which is now the top, is, as we mentioned before, the origin. Now, I don't know if you notice here, this is because of the 3, the parabola is getting closer to your y-axis. And here is a series of graphs in which they illustrate the relationship of the various shapes of the parabola. Now, this one right here is when a is 1, and you have this line coming up like so, this reddish line. Now, if you have the a term that's in front of the x squared, here it's 1, but if you have it as 4, notice what happens. That instead of being further away from the y-axis, it gets closer. And if this were 5, it would be closer still. Well, how about if it were a fraction, like 1/4? Okay? Again, compared to a 1 here, 1/4 opens it up much more. And if you had 1/8, it would even be more open. And notice now that here you have f of x equal x squared, where a is 1. And then down over here you have f of x equals a negative 1. Again, instead of opening upward, having a negative 1 as our a term, it opens downward. And if you took this reddish line and if you bent this diagram at the x-axis, you would see this is what we call a reflection of the upward opening parabola, but now it's reflecting downward. And what caused that? Well, our 1 here was positive, that opens upward. Here our a, which is negative 1, it's opening downward and is a reflection of this. So this particular diagram, excellent, and if I were a student, I'd kind of sketch this. Doesn't have to be super accurate, but just to know what's happening as you graph these functions. So here they're giving us some values and describing again the domain and in a sense a range. And again, pause it, read it over, and we'll just keep the tape moving though. Now, this is the second of the 3 equations we're looking at. Here we're taking a, but now our x is expanded and there's something else within it that's going to be squared. Okay? So let's look this over here. So here, instead of there just being one term here, we've added some other terms. And our x value is going to be modified somewhat by the constant h, which will be some number. But again, we're going to square that and then apply the a to it. Remember, if a is negative, the parabola will open downward. If a is positive, it's going to open upward. But watch what happens when we add something to this. And this gives you some background. And we want to graph now this one. So what have we done? Now notice a here is going to be a 1. And we've added a -2 to what we will square. Okay. So we put in 0 and we get various points. And notice our vertex will be where y is 0. Because, as you see, and now they're illustrating these points plotted. Now, if there were no -2 there, where would this graph be? Well, it would be at the origin. So here we've put in a -2 in the form of x here, but notice what's happening. Instead of being at a -2 as we might think, it shifts from the origin 2 places to the right in a positive direction. So as we look at something like this function plus, or I should say -2, is graphed on a graph at a +2. So we're getting a little form here. Now, suppose this were a -3. Everything the same, but this were a -3. Well, this graph would shift to a +3. How about if this became a +2 here? X plus 2. It would shift to a -2. It'd be the same shape, because if a is just 1, this is our basic shape. And we will see then, as we look at this, that the h value here, if h is h all by itself is positive, the negative here is in the formula, we'll shift that to the right. Okay, let's go on. Now, in the last formula, we are doing basically this part. There's our h. Remember, that's some value along the x-axis. And k now, k you might recall in that old slope-intercept formula, y equals mx plus b. This k out here is where it is in regard to the y-axis. This is in regard to the x-axis. This is in regard to the y-axis. So it's going to shift. All right, let's take a look at it. And again, it gives you all of this that you can pause and read. But let's look at this graph. Wow. And what do we know from looking at this? Well, A is what? Negative. So this is going to open upward or downward? Well, because it's negative, it's going to open up downward. Now, in regard to your axis of symmetry, this is a +3. So it's going to shift it over to a -3 on the x-axis. And this is -1. It's going to shift this down now. Actually, this sign is, as is read, a negative. It's going to shift it down to a -1 on the y-axis. So again, just from looking at it, we're getting lots of material. So there are the points, and that would be tedious. That's why it's nice to have a graphing calculator to do this. And then this is your vertex. That's the highest point there. And there it is right there. So we said in regard to the -1/2, it's going to be a little wider than if it were a -1. Spreads out the lines of our, or the curve of our parabola. And we said it was going to be down 1. And it's down 1. There's our y-axis, -1. And this was +3, not here, but opposite sign, and there it is. So we sort of predicted what was happening from the information in our graph. Now, in our next section, we're going to use this formula, which I often refer to as the Vertex Formula, and that'll wrap this up.